Hello, my name is Michelle. In a previous video, I discussed how I created an AXI master driver and I communicated that to an AXI slave BRAM, which was an IP, so that's how I knew that my master worked. But I have to admit that that was only being done in simulation. I wasn't doing it on the hardware, mainly because I just didn't know how to initiate it from the PS side on the SOC FPGA. Then after I wrote that, I actually wrote my AXI slave. And this waveform right now is a simulation. And it's showing how that my AXI master driver wrote data to the BRAM, and then it got data back from the BRAM when I asked for a read. So it showed it worked definitely in simulation. And like I said, that's all covered in a previous video. However, this video is to literally show how you can initiate it from the PS side, which is the microcontroller side, have it work on the PL side, which is the FPGA side, and prove in this case that my slave code works on hardware in this case. And then, of course, if my slave code works and it works with my master, then my master by should work as well. Um, so the point is, let's go ahead and show you the design in this. So it turns out, um, here's my PS system right here. And by the way, my cursor, I've tried everything to get my pointer to show. Well, it is at this point, so good. We'll just keep it going. Sometimes it doesn't show. But the point is, so here's my processor, right? It's the microcontroller. And it has two ports, an AXI master, that's a GP0 for general purpose, and another AXI master for general purpose 1, so 0 and 1. In this case, we're going to task general purpose 0 to do a write, and we're going to task our general purpose 1 to do a read. Right now, so this, in this case on the read, I'm going to point out that if you chase this line, it's a master to a slave. That's how these things work. These are IPs, so I didn't write this code. So this stuff is all generated by Xilinx, I believe. And so whoever wrote this code, they're selling it. It's been proven it works. It works on hardware. So it's not something I wrote, but I'm going to use some of this technology to prove something I wrote works. Anyway, so this smart connector is, I believe the point of that is because in SOC FPGAs, a Zinc Z7 020 in this case, they are using AXI 3 as how it comes out of the processor. And most AXI is AXI 4. So it converts basically, as far as I believe that's what this is doing, is converting it from AXI 3 to AXI 4. So then what comes out of this port right here, this master to this slave, this I believe is probably AXI 4. And you could tell if you went and looked at the uh, the well, no, this still looks like it might be 3. Huh, I'm not 100% sure. But because actually 4 has a little bit of a different signals than 3 has. Oh, well, in this case though, then this controller, BRAM controller, again, this is the read section. It would actually say, okay, I'm sending a command from the processor saying I want to read an address, right? So then it would tell the command to this block memory gen, this controller would, that here's the address I want, and I'd like to read that information from it. And you'll notice that this is attached to port B of the block memory generator. So this is basically a BRAM, a block RAM. Uh, Basically, data stored at a certain address. All right, well, on the right side, again, I want to test my code, so we'll see it. So let's go back over here to the processor, and we go at the output there. That master is talking to another Smart Connect. Like I said, because definitely my slave is a AXI 4 for sure. So here, let's just, out of curiosity, let's go see if it's strictly AXI 4. Now, there's still some interesting code here. So I'm not sure how this is translating into AXI 4 and why. I don't, again, I've didn't write this. I don't know the details, what gets created. When I told this block designer to attach my device to that, it created that on its own. So why it's there and how what it's doing exactly other than translating, I don't know. Anyways, so it is going from a master to a slave, which is my slave, the one I wrote. And in this case, I'm taking that data and sending it out through my BRAM port to the BRAM port A to write. And so we're going to initiate a command here in the processor to write data. It's going to communicate to my code and say, hey, write to the BRAM. Then mine's going to go, okay, BRAM, at this address, here's the data I want you to write there. And then, of course, after I write data, then I'm going to initiate a command to do a read. The read will go through this path right here and read from the BRAM. So I'm going to go ahead and show that it works first, and then we'll explain how it worked and what I did. All right, so first of all, I'm going to show you that we got our COM port up and running. The FPGA is ready to go. I've already written the code to do the write and the read. Basically, I'll go ahead and show you that real quick. So basically, I've just told it to instantiate the ports, and here I'm saying write out at this base address, like 10 different addresses, dead beef, and then increment the very end of it with a counter. Then I said I want to read. Here's what I'm saying. I'm reading the data off of it, and then once it writes and reads, it was successful. Otherwise, it fails, right? Okay, so here I'm basically going to here, and I'm going to go ahead and tell it to run. Run on the hardware. Come on, pop up. There we go. Run as on the hardware. And so right now it's going to go out and program my FPGA. There you go. And we'll open up our COM port so we can see that it's programmed FPGA. And sure enough, it started, it wrote it, and then basically it read. And sure enough, at these addresses, there it is. This is what it read from it. You might sit and say, well, wait a minute. How do I know that? I mean, again, the part that reads is an IP. How do I know that it wrote it right? Okay, that's fair. So let's go ahead and let's change it from dead beef to let's change it to deed beef. How's that sound, huh? So I'll save that information. I'll go back to the code here because I made a change. I need to build it. And all right, so now that it's building here, and then when it's done, we'll run it again. So let's run it again. And if my AXI slave works correctly, it should read deed beef instead of dead beef. And oops, get my COM port open. And we're waiting for it to program it right now. There it goes. And there it is. Deed beef, and the numbers incrementing. So sure enough, I have proven right now that my code actually works. All right, so let's go take a look at my code and see what's going on here. So like I said, this is on the PS side. Basically, we're just instantiating the PS, which we're telling it I want to write out, and it's going to write out through AXI through this AXI to the AXI slave, and in this case, we're going to read from the AXI BRAM controller. But again, these are all going through AXI communications. So if you look at my code, basically my port on my code says, okay, well here's my AXI 4 signals, and then here's my BRAM. So the AXI message will come in from a master to my slave, and then I'll write out to the controller the data that's needed, the address and the data needed. And so basically I have a state machine in here that does, where I'm idle, and then I'm getting data, I wait, and then I'm sending it out. So basically, I'm using a state machine to send out the data. If you go and look, basically, this is the AXI process to get the address that's needed, because that's the first thing AXI sends. And then this is actually the process that takes the data that it gets and sends it out to the BRAM. And of course, the BRAM signals are linked here, and the BRAM is over on the top section, or obviously the block design that got created by the block design tool. This is my read code down here. I didn't test it in this tutorial. I just did just the right. And so there you go. I mean, it's pretty basic stuff here. Like I said, when you we've already seen that my code was connected to it. It was built into it. When you go into the Vitas tool, I instantiated an application with my platform as my platform, with my BSP in my application. You know, here's my source code, and it's basically the AXI VRAM source code. And there you go. So yes, my AXI master does communicate in SIM to my AXI slave, and now I have proven that my AXI slave does communicate to a AXI master in real hardware, and proving, therefore, that this actually works. And so there you go. My AXI master and AXI slave code does work. Well, thank you for your time. I hope you enjoyed the video, and have a good day.